Okay, let me see if, yes. Let's start my VS Code. Right. Okay, looks like I'm live. Let me know, guys, if you can hear my voice. Again, it is as usual a Sunday 4 p.m. And let us connect here and let us try to learn something new. And today's topic is around threads, around TPL task parallel library, which came in .NET 4.0, and around the async and await things out there, right? Now, why this topic I have chosen for this week out here is uh, today also I see a lot of developers, when they're in the right threading code, they use thread.start. So I'm really not sure that why thread.start is used, right? So my main goal of this so-called as knowledge sharing session is just to try to understand, or just to try to put forward, that what is the difference between a thread, what is the difference between TPL, the task parallel library, and this new thing called as async and await, right? So yes, so welcome everyone. I can see Neeraj again, and Gyan and everyone. So I want to put forward, first this question to everyone out there. What do you think? What is the difference between a thread and a task? So we have system.threading very quickly. I'll resume my share out here. So over here, you can see we have this system.threading and we have this system.task, right? So what is so special about task, that we can't do with threads? Uh, and what is so special about, why do we need task? Thread is all good, right? So if I want to run two functions in parallel, if I want to run two code in parallel, thread does the work. So what is so special about task? So go ahead, put down on the chat that why you think that I should use a TPL, or in what scenarios I should use a TPL, and in what scenarios I should use a task. Yes. And very quickly, just for everyone's information out here, definitely, I would suggest, if you are a Questpond member, I would suggest to go and watch my C# threading and Q&A videos, which are very much dedicated to threading. So here I've just talked about threading. What is threading? What is lock? What is mutex? What is semaphore? What is semaphore versus semaphore slim? What is the difference between a TPL and a task, and so on, right? So I have like 4 or 5 hours of session, which is only dedicated towards threading out there. But over here now, today the goal is to just quickly understand threading and TPL, right? Okay, so I can see some answers out there. Let me just look into it. TPL is for multi-core. That is like hitting the bullseye. From Shishir Shukla. TPL is for multi-core. Very good. But okay, and then we have Jalaj here. Jalaj says that threads are concurrent and tasks are parallel. So, okay, concurrent and parallel. Now, I don't want to go into the discussion of concurrent and parallel. So, but I can look at yes. So I think like Jalaj has again put a proper what do you call, a more improvised statement, and that makes a lot of sense. Guys, please watch your chat as well. In the chat, I'm trying to interact because this is YouTube, right? If I put everyone on the microphone, we'll all go crazy. So two answers I can see, one from Shishir, one from Jalaj. Shishir says TPL is for multi-core. So isn't like Shishir thread is also for multi-core? Why not? Like the whole goal of thread was that I want to run parallelly, right? And TPL automatically uses code in multiple cores. I think that's the right thing. So I'm going to go and copy Jalaj's statement out here and set the context of today's session, right? So I'm going to go and set the context of today's session by just putting that statement, from one of our audience out there, that TPL automatically uses multi-core, uses code in multi-core, or uses multiple core. What does it mean? So here it is. Let me see if I can draw a diagram out here. Now, the whole goal of thread or TPL is that you want to run the code parallelly. You want to run some task parallelly, right? So here's how it is. So you have, let's say, your some code out there. So you have core one. So let's say you have two cores in your machine. Assume, like, I'm just for the understanding purpose, this is my two core out here, right? If you say that you want to really run parallelly, let's say if you have function one which is running on one thread, and if you have function two which is running on one thread, right? Let us say that function one is doing some task and function two is doing some task. Then function one should actually run over here on this hardware, on this core, right? And when you say function two, right, and function two should run on this one. This is actual parallelism, isn't it? If this happens, that means that you are utilizing your hardwares properly. So, that statement out here, that TPL automatically uses multiple cores. In other words, that both of my functions will run parallelly. But now, that there can be a situation where if you have a thread affinity, I'm just putting these words out here, thread affinity, right? If there isn't thread affinity means when you go and say new thread and you say thread.start, what happens is, even though you have two cores out there, but because you have a thread affinity towards one core for whatever reason, right? What happens is both of this function, try to run on the same core. So function one runs, then after some time the core gives time to function two, then function one runs again, and then again it gives some type to function two. So it 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 the function one actually puts something out. The function one, the core actually gives time, or I'll say this is time slicing. Okay, I'm so sorry. That must be a right word to use here. Time slicing. Time slicing means some time to function one, some time to function two, then switch the context, then again switch the context. This one is termed as context switch. So that means that when so there are two kinds of things which can happen, which your developer will not be probably be aware of, right? That one is uh, you are actually running parallelly, or you are actually doing time slicing, or you are actually doing context switching. Now, if you are doing context switching, if this is the condition, right, then you are not doing parallel programming. As one of our friends said, concurrent. You are concurrent, but you are not parallel. Okay, I know that all these words are like together, but the point here is that you have one road and all the cars are running on that road. If you really want to drive parallelly, then you need to have two roads and both the cars should run on both the other roads, right? Or else you will just have a traffic jam out there. Now, when you do threading, this happens: time slicing, context switching. It is your responsibility as a developer to ensure that this thread will run on this core or this thread will run on this core. So by default, there is a thread affinity. When I say thread one, thread X is equal to new thread and X dot start. When I use task parallel library, it actually goes and handles this. It says that, okay, like, so you have like this much load and you want to run both of these loads in parallel. So let me see, if core one is free, I will run over there. If core two is not free, then I will try for core three. So TPL has this automatic code. Again, this sentence is coming from the audience itself, and I'm just trying to put more context in this session. It automatically uses the code in multiple cores, right? So that's what it is: time slicing, and or I will say rather. So the question you have to ask yourself: are you doing time slicing or are you doing actual parallel processing? Right now, let me go ahead and let me see if there are any questions out there, so I can see like so. So I can see one of the inputs from Adam out there. Task use thread from thread pool to execute job and use low level thread to execute this job. Fine. So yes, what Adam said is absolutely right. That task does use threads, but task adds extra logic to it. So I'm not here to now say that task uses threads or not. Right? I'm just trying to say that what a task does and what a thread does not do. So you are absolutely right, Adam, that the task internally uses threads, right? It can use a thread pool. It does everything automatically for us. But the main thing is that it utilizes your hardware. So yeah, Ravi, hi sir, good evening. Can you change the Visual Studio Code background theme? It was not visible clearly. Okay. So yeah, Ravi, don't worry about the theme. I'll try to it's a black theme. It's a good theme. Let me try to change the theme. Thread is independent execution of path. So that's different. So I'm sorry, I've come down here on the chat and I can see. So any questions here, guys? If you understood this, if you understood this concept here, that thread and task. So in the sense now, what I will do is, let me go here. Let me go and resume my share. And let me try to do a demo out here. So let me try to do a demo. This theme, I don't know why the theme is not good out there. And what I will do is, let me do like this. Let me do this demo using .NET Core and VS Code. Let me try to do this demo using VS Code and .NET Core. So what I'm going to do is, I will go to my E drive out here. Let me make this display settings. Let me make it bigger. Remember, guys, this session which I'm taking completely on the fly. I have really not come prepared as such. I know what is a thread, what is a task. So if some mistakes are happening out here, please excuse me. So actually, 10 minutes before I was writing some code of thread and trying to see if it is working or not. But the point here is, to communicate the actual use of task and thread. And remember that as we are doing this every Sunday, right, at 4 o'clock. So really, I take up a topic, which comes on the email or it comes on the YouTube channel, and then I start preparing like at 3 o'clock. So sometimes, my preparation is really very shallow, you can say, but I can tell you that it will definitely help you understand that. It will definitely help you to understand how to go ahead, right? So let me see that what best I can do. And today what I'll do, I will not use Visual Studio. So with that, you will also get a perspective of how to use VS Code with .NET Core, right? So here it is, thread and TPL. Okay. So I'm going to go and copy this. Let me use VS Code. Let me open up the folder. What is so bad about this black theme? I can change it. I never changed this theme. I really liked it. File preferences. I can change this color theme to light Visual Studio white. Yeah, I hope that will help. So I'm going to go now and open up the folder, and I will just take this folder out here. Let's go ahead and create a simple a task code. Let's go and run some task code. Let's go and run some TPL code, and let us see that it is doing time slicing or it is not doing time slicing, right? So let us see how we can do this. Let me see if any other questions out there. Okay, right. So I'll come to that. I'll come to all the questions, guys. Don't worry. I'll come to all of the questions. So first thing, guys, this is .NET VS Code out here. And, in Visual Studio, you do a file, new project, console.NET Core, right? But here you need to use this .NET commands, .NET new console. So I'm going to go and create a console library out here. You can see that's in console library which I've created. So I will just go out here. Now here, what we will do is let us use threads. So my goal here is now to demonstrate system.threading. So the goal here is to demonstrate that thread does context switching and task parallel library does not do context switching. That is the goal out here, right? So what I will do is I will go ahead, I will create a method here. Let us say static void some heavy task. I'm just trying to practice that, how it looks to code in VS Code. So, but definitely for big projects, I will not be using VS Code. The luxury, the shine of Visual Studio, it is so infatuating. I can't leave it really. So, but still, if you are on Mac or if you are on some other OS, then this is the only way to do it. So here it is. It also has code snippets, so I can just use this for. Yeah. So what I'll do is a big loop out here. Some big loop out here. Must be a loop inside a loop to just generate some heavy task. A bad way of doing it, but because just with the task.delay, it does not really, or thread.delay does not work. So you can see I've just made one loop inside another loop, right? Must be, I should find out a better way of doing a heavy task. So here it is. I've just, because at the end of the day, if you don't pressurize the CPU, you won't really get a good result out there. If you just use a simple for loop of 100, it won't do any kind of context switching because the load is very less, right? So you can see here, I've just went ahead and I have created a loop out here. and I'll just copy paste this. So there's some heavy task. I1, I2, I3. Okay, great. Some heavy task. This is doing something out here. Let me also create some small memory pressure out there by just declaring some variable. So I have this some heavy task, and what I will do is I'll just create some exact copy of some heavy task one as well, right? So two codes I've written out here exactly same. Where is it? Some heavy task. Okay. Oh, when you copy it, this is so sad. You have to copy it like this. Okay. Fine. Okay. So there it is. Two methods out here doing some heavy task out here, right? So I'm going to go and create a thread. T1 is equal to new thread. Let's write some sample code. The VS Code is pretty much looks like Visual Studio now. And T2 like right, and T1 dot start and T2 dot start. Yep. And I will just put a console dot read here so that we don't want this, because when the threads will start, it will just go ahead and execute both of these tasks and it will just go off, right? Great. So you can see here, this is an application out here which is having a heavy task and a heavy task one. I've just spawned two threads. So that means now I will have three threads actually. If you ask me, in this application, we will have actually three threads. So this is how it will be. So in this application, one thread, which will run the static void main. The another thread which will run this some heavy task, and the another thread which will run this some heavy task one. Three threads, right? At least my expectation is that this T2 and T1 should run on two different cores. Now remember, guys, at the end of the day, the task scheduling is very much handled by the operating system. The operating system is the king. So even though if I try to do a lot of things from here, it is very much possible that the operating system, depending on the pressure on my computer at this moment, depending on a lot of things, he can schedule it. He can override things and say that, no, like you guys, I know that you want to run parallelly, but I can't do it for you because the operating system has to be alive first, right? So operating system gets the top priority. So it is possible that when I show this demo, sometimes you will see something which is unusual, right? It is possible. But most of the time, I think we should see a proper result. So now I'm going to go and build this application. Remember, this is VS Code, and I'm using the .NET CLI. So I have to say .NET build. So there it is. It builds it. .NET build. And there it is. So you can see now when I do a .NET build at the left-hand side, I can see my bin folders. I can see my exe now out there, and I can go and now try to run the exe. But now what I would like to see out here is I would like to see context switching. As I've said that if this is, as I've said that if this thread out here is doing time slicing, then the context, the number of context switches should increase a lot, right? So I'm going to go and open up my performance monitor. I hope everybody is aware of performance monitor. Performance monitor helps you to track your performance counters. So in your operating system, there are lots of performance counters, like how much time it took to open your browser, how much time it took to get a particular request, how much time the garbage collector ran, how much time the SQL server restarted. So a lot of counters are there, and you can go and you can track those counters, and you can know like if your application is doing good, if your computer is doing good, and so on, right? So hordes of counters out there, and I won't really go into that. And you can see this is the performance counter screen out here. So let me go here. At this moment, you can see this is the graphical version, which it is running out here. And it also has, how do you say, you can see a value as well, single value as well. So if you're not a graphical person, you want to just watch the values. So here it is, the processor time. But at this moment, my interest is not the processor time. My interest is context switching of the CPU, context switching of the processor, right? So I'm going to go and remove all these counters out here. Right click and add. Guys, any questions, please put out there. Once I do this demo, I'll come back to questions. We can have discussions, right? So I'll just, and the whole goal here is that once you see something visually, for example, if you see, oh, this is context switching, right? It becomes very easy to remember the concept, right? And the most important part is that when I show all these demos out here, if you have some issue in production, assume that you go in a production, somebody says like, your application is slow, right? So is it that developer have used only threading and they are not aware of TPL? So must be you can go and you can add these counters and see it, right? So again, here it is as we are doing this TPL versus threads, these other things also we are learning. So I'm going to go now. There are lots of counters out here, but the one specifically which I discussed, um, context switching, is in system. Now you must be asking that, Shiv, how do you know that this context switches per second is in system? Well, because there are 5 or 6 counters which I use to start with, like the processor, the RAM. If it is ASP.NET, then the session variables, the cache. So there are some counters which I know in which category they belong because of the habit what I have, right? So but here this is the system category. Inside this we have context switches per second. So I'm going to go and just take this. Now remember that already context switching is happening in this computer. If you see at this moment that there is a number out there, let me go and see a version which is graphical. So here it is, it's a graphical version out there. The value is quite, because of the scale, the value is quite high at this moment. What I'll do is I'll go and change this to, must be a bit low out there so that we can actually see the values. Okay, there it is, great. So at this moment, this is the context switches per second, what is happening in my computer. I repeat this sentence again. This is the context switches per second, which is happening in my computer. I've already talked about context switching, right? It is all flat. It is moving, hovering around this 20 thing out here. I can just clear it. Right. This is what it's right. It's okay. Something is happening out there. I'm not sure. I don't know. Okay, something has gone bad out there. What happened? What happened? Okay, can you tell me, admin, what happened? Because I was on Zoom. Voice breaked. Okay, my voice breaked. Is it? Okay, let me. Okay, I didn't see the chat out there. Right. Okay, I hope that everybody can see my screen. Right. Let me see. Okay. Strange. Okay, now okay, fine. Okay, fine, guys. I think that there was some disturbance out there. I'm back again. Okay. Okay, let me, where was I? Okay, here it is, guys. Here it is the context switches per second, which is like approximately it is hovering around 20 and must be it is going something at the top. Now, if I go and run this application out here, so let us see where our application is. So our application is here. Let me go and reveal this in File Explorer and let me try to run that exe out here and let us see what happens. So let me go out there. Quite tricky when you're switching your windows as well. The context switches happen, so it's very difficult to figure out sometimes when the context switches are happening and when not, right? Okay, one more thing which I was trying to point here is you can't measure that how much CPU cycle is used by an application. You can measure RAM. I just want to make an important statement. You can measure RAM, you can measure what you call memory usage, but it is very, very difficult to measure processor time. I cannot say that, okay, some 100 CPU cycle has been just running on this, because processor is shared, right? So that's why I'm measuring context switches per second across my computer. So you can see now this is what it is out here. It is pretty much now flat. So let us check that. Very difficult demo to be shown live, frankly, guys. But let me try my best what I can, right? And these are the kind of experiments, which can help us to understand the application better. So it is flat like 2040, maximum 2040. I'm going to go and run this exe, which is compiled out here, and I'll just click on this. So that's a big, huge exe out there, which will run. And you can see that exe is running, and you can see the context switches has shooted up. You can see the number of context switches has shooted up. If you see this shoot here, and then you can see this shoot here. This shoot is very abnormal as compared to the previous one. So that means that when I'm using threads out there, it does context switching, right? So you can see these two shoots out here. I'll just go and close this because I have a very good RAM and a good processing power. So it just completes those for loop very faster. But you can see these two big shoots out here are a clear indication that your context switches per second increases. Context switches per second. When I say context switches per second, I mean context switches per second. I can go and I can just take a snip of this. So if you see this graph out here, this one here was very normal till here. This was like, it was in certain limits, it was moving. This is the time I started running my exe. And the time I run my exe, all that thread dot started, and the context switches, this, what you see, this graph out here is context switch per second. So sometimes that heavy method 1 runs, and then heavy method 2 runs, and then switch. Heavy method 1 runs, switch, heavy method 2 runs, right? Context switching. If I go and change this code to a TPL, if I now go and change this code to a TPL, and I leave this as a homework to everyone, I'll not be showing it here live, but you can try this out. You can go and you can change this to TPL. Just the syntaxes are pretty much same. So like I can go and say this is task, new task. So again, now guys, as you know, one of our friend Adam has said out here that task is a cover on the thread. So it's basically, if you see the namespace, threading.task, there it is, right? So new task. Look at the syntaxes, almost same out there. Even that start is just a start. So this is again a task. So go ahead and try this out, and then try to run the context switches per second. You can see almost the same code out here, but this will not show those context switches. You won't see those big context switches as I've seen now, right? So I want to go now to the audience out here. Did we understand what is context switching? Did we understand how TPL can help us? Let me know if there are any questions. So I'm going to go and first keep that screen out there. So take that as a homework, guys. Please take it as a homework. So because we have other topics to complete. But if you go and if you run the perfmon, it will be the same thing. Okay, must be I can just pause the share. So let me go back and see the questions. Hey DJ, how are you? Yes. Okay, I can see a question out here. Sir, this perfmon, very good question. This is a very good question. Guys, please put down your questions. I'm open for questions. So as we said that task parallel library runs parallel while thread runs time slicing. Thread runs concurrent. Thread does context switching, right? In short, in one sentence, if I conclude, henceforth, please use task. Just say task.start. That's more important, right? Also, like one question which has come here and which is very, very important. I think I should answer this. The question is that how does this work in .NET Core? Perfmon, very good question. Very good question. Perfmon, this perfmon tool, what you see out here. So let me just go there. Perfmon tool. Let me put this question out here. So let me try to understand that question. What you're saying is perfmon tool is only available in Windows. Absolutely. Performance counters. This tool specifically perfmon, it only runs on Windows operating system. If I am on Mac or I am on Linux, then if I have a .NET Core application, how can I track it? Right? So very good question out there. So the .NET CLI, right? the .NET CLI has given us performance counter. So here it is. What you can do is you can use these two commands out here. I knew that someone is going to ask it. Actually, I was going to go and show the demo by using this. Then I thought that everybody is so comfortable with perfmon. I thought I will start using that, right? But here it is. What you should do is, for example, now if you want to go and monitor in your in Linux, or if you want to go and monitor on Mac, then you have to do the following. So if you should run this thread TPL, whatever is your exe, and you should get from there something called as the process ID. So here it is. I'm going to go and run the thread TPL out here, and I will go to my task manager. And from here, now you have to figure out that how do you get the process ID from Linux, right? So you can see now very quickly, you will see two exes out here. One is, you can see this is the console window host. So don't take this. Look at the second one, thread TPL 30464. In case if you're not seeing this PID, please ensure that you select this, and you should have the PID out here, 30464. Now what you can do is you can go here, you can open up your command prompt and ensure that you have the .NET CLI installed out here. And then you can go and you can say here, counter, what is that number? 30464. So 30464. 30464. And remember, they have also given lots of events out there by which you can go and you can track. So you can see now it is trying to collect data. Oh my goodness, look at my fonts. I'll just go and make my fonts 20. Okay, there it is. You can see now that's by using the .NET CLI out there. So I can know garbage collector, I can know context switches, I can there are a lot of list of performance counters out here which you can track. So you don't have to use the perfmon of Windows. But remember, the perfmon of Windows is very, very a kind of a tool, which is useful, which is used by the admins. So the administrators out there who are working on Windows, they use that tool a lot. But in case if you're a developer who wants to track using your favorite .NET tool, then this is what it is. The GC1, GC0, the thread pool, and a lot of other counters. If you want to know the list of counters, so you can see now this is running. If you want to quit from this, you can see at the top Q to quit. So you can just quit out here. There it is. And if you want to just know that which are the performance counters which are supported, that is the second command out there, .NET counter list. You can just go and you can fire this, and you can know the list of counters which is available at this moment. I know that this is not as extensive as what we have in our Windows, but it is still very good to start with, right? So that's the answer for the one question out there. How do I track these performance counters which are non-Windows, right? Okay, let me go back now. Okay, so let us start the questions here. Yes, absolutely, there is Sachin. Okay, perf tool. Yeah, I know that every operating system. So very good input from Sachin here, saying that, sir, there is a tool called as perf tool, absolutely out there. And I have not done Linux. But what you can do is you can use this .NET counter. So you are, let's say that I don't have knowledge of perf tool, I can still use it and just track it in my application, right? Okay, someone asked me in the interview, what is synchronization context? Wow, that synchronization context. So there is a question from Jalaj here. What is synchronization context? And let us see some other inputs out here. Task does not do context switching while thread does. Yes, absolutely, Dilshad. That's the right sentence out there. Task, the name itself is Task Parallel Library. The name is TPL, Task Parallel Library. It does not do context switching. I remember that, when I was working in .NET 2.0, we have to write so much code to really make it parallel. We have to use that set CPU mask. And then we used to say, okay, and we have to write a lot of code. First thing we used to query the CPU saying that, okay, on this CPU, is the antivirus running? Don't run it there. Then run it on the second CPU. So we have to go and do a loop, find out, how many cores are there in the machine. Then we have to go and say set CPU mask 001 means it will go to the first CPU. 000010 means to the second CPU. Oh God, it was tough. This TPL just made our life easy, right? Okay. Right. So, okay, Shishir. So Shishir's question and Jalaj's question, both of them I will answer in one go. I did not come prepared for this, but I will try to answer this, right? The question from Shishir and the question from Jalaj, they are both very much connected together. What is synchronization context and why do we use async and await, right? Okay, let me go back and switch and let us go to our thing here. Okay, resume. Okay, on this channel itself, on the Questpond video itself, you will find that there is one video which says the difference between asynchronous and parallel. Okay, let me just put down here. I don't know how many of you guys have watched that video. That video is very dear to me, and we have more 2 hours of video inside Questpond videos dedicated to async and parallel. Right? Parallel processing, parallel, and async. Let me just talk about this. Right? Parallel and async. Both of them are different. I think we had a special lecture on this. We had one special lecture where I said that async is not parallel. I clearly said that async is not parallel, right? Now, when I'm using this TPL, right? When I'm using this TPL, I mean parallel, means I'm going to go and run two things parallelly. If you see, when people talk about parallel word, they use the word worker threads. I don't know if you ever seen it, why they use, I don't like the word worker, right? But I can understand why they use the word worker thread, which is very much in sync with what we do in real time. In real time, think about if you have some task. Let us say someone says, I want to wash clothes and I want to cook food. So what they'll do is say, okay, these are two parallel tasks. They are not connected with each other. They are not at all connected with each other. There is no exchange of information when you're doing washing, washing of your clothes. It's nothing to do with cooking of the food, right? There can be something, but not really directly, right? So what you can do, you can say, okay, one worker, one person out there, he just cooks the food. Another person dedicated, he just goes and washes the clothes, right? Both of them are not connected. You run super fast. Remember, parallel processing, when you're actually saying, I want to run parallel, first thing you should take those tasks which has no connection with each other. If you take a task, for example, you'll say, okay, as the PDF is getting created, I want to also go and convert it to Word. Now, this is not parallel. You should say that, okay, here PDF is getting created and there is some another task out there, parsing of some file. Yes, both are parallel. A good choice of parallel is, when the two tasks are not connected. The time the two starts exchanging information like this, you lose the benefit of parallel processing. It is gone, right? But now, fine. So we need parallel processing when you want to run really super fast, right? Your goal in your head, the thing is performance, right? But now think about, you say, no, like I don't want to really run fast. I want to use my CPU to the max. So I have this one core out there. I want him to do time slicing. I want him to do concurrent. It's not about fast. It's just like, I just want to use one worker. If I use two worker, I have to pay two salaries. So for example, now let us say, if you're saying like, making tea, making a breakfast in the morning, right? So you'll say, okay, I'll first go and put the tea. Let's say I start to boil it. Then I say, I'll start, doing my sandwiches. And then I'll go back and put some milk. Yes. Here for this task, to put two workers out there does not make sense. Please understand first the concept. First thing is in the head. If your head is not right, then you won't understand why that word async is, right? So async, what async says is that we do not intend to run fast. That's not the goal here. Performance is not the goal here. The intent is that we want to just run like this and use that one worker thread in a very optimal way. That is what this async is all about. So async, so he says, okay, run this async, wait. Now run this async, you wait, and we complete this only with one processor. You want to run fast, then you need two processors. So parallel and concurrency. So this is also termed as concurrency. Guys, please go and see my video on this channel, parallel versus concurrency. You will understand it, right? So when you are saying you want to run parallel, the technical word in .NET is TPL. When you say you want to run async, you're going to have only one thread. In that one thread, he will run these two tasks. You get a feel of parallelism. Please understand. You are a human. You get a feel of parallelism. Okay, file is getting downloaded and this is happening, right? So async and await is concurrent, while parallel means two parallel, right? So I first thing, let me know if this is understood. This is the most important part. So if I just put, if I try to put here, this is parallel. If I put here, this is async, concurrent. Here, you are using two processors. It is utilizing resources. You are using one processor. Here, performance is the main important thing. Your main in your head is that I need to be good in performance. Here it is that I want to use maximum, utilize my resources in a proper way, not really performance, right? Utilize my course in a proper way, right? Here, both of these tasks are very, very independent. They are completely independent. They have to be independent. If they are not independent, then you again end up into kind of an async, right? Here, the tasks are correlated. There is some connection, right? Something is there where you want to exchange information, you want to halt, you want to pause. Like as someone said out there, web API. So in web API, I will post it, but the client has to get it afterwards. So there is a connection of the client and the web API getting posted. These are not two things. Like it is not that the client just shoots it and he goes away. No, he again waits it. Now in that case, that's why, if you look at all your web API has those async and await in the methods, right? So guys, any questions on this concept first thing? Any query on this thing, that parallel versus concurrency, parallel versus async? If you understand this, then other things are easy. Right. So Shishir, coming to your question out there, like we can see that Shishir has put a question. Then I will go to Jalaj. Why do we use async and await in web API? Because in web API, the client has to wait. The client is not a disconnected thing. He has to wait. He has to say, I will post you, and then I have to wait. So that means now in one thread, he will try to serve the client as well. He will try to serve the server as well, and he will complete it. Okay. Now coming to the synchronization context. Synchronization context. It is very difficult to demo here, Jalaj, the synchronization context. But the synchronization context, what happens is very quickly. So first thing, any questions before I move ahead? Let me not rush. Any questions on this parallel versus async and concurrency? So let me go and point the video out here. So parallel versus concurrency. Okay. So, these ads. So I'm going to go and paste it out here, guys. There it is. That's my video which I posted on the chat, which is parallel versus concurrency. Yeah, let me know any questions on the concept. Right. So now coming to this, so I can see that there are no questions out here. Let me wait for a minute. This YouTube is so slow that I would like to wait and see the questions out there. Right. Yep. Right. So there's one more question which has popped up here, and let me take up this question. The question says that, again, the same thing, synchronization context. I think a lot of people are asking for synchronization context. Let me talk about it. Synchronization context. Synchronization context. I'm not sure how it is asked in the interviews. One, I can see question from Shishir and another one from Mahesh out here. What exactly is synchronization context? So the synchronization context is in connection with async. So what happens in async, as I've said, you have a thread running here. The thread goes and starts another process in async, right? And let's say this is a big thread out here, which is running for, whatever, like 20 minutes, let's say, not 20 minutes, like let's say 60 seconds or whatever, right? And your thread continues ahead, right? He continues ahead, right? Now what happens is, after a certain time, this thread says, I am done, right? I am done. And he actually tries to ping back. Now at this moment, at this juncture, you need to sync up his context, with this context. So what happens here is there is one more small thread spawned up. A small thread spawns up, which takes this context and syncs up, and then you move ahead. This is termed as the synchronization context. So just answering your question, Shishir, out there, what exactly is synchronization context? You can look at my video of my TPL versus task out there, where I've explained, how the synchronization context works. So I've explained with the win form. So that would really help you, right? So that's the answer out there. So async and await. I will not show the demo of async and await. There are lots of videos in this channel itself, how to write an async and await code. There are lots of codes, out there. But TPL and async and await are different fundamentals, right? So guys, let's summarize, what we have learned. Let us try to summarize here. And if any questions, guys, please put down out there. So from this lesson, what we can summarize is following. First is parallel running and time slicing are two different things. Time slicing is not really parallel. In this, only one core is used, right? Time slicing, you can say, or context switching, right? Second, TPL does actual parallel. It implements the automatic parallel for us. While that does not happen in threading, actually. In threading, by default, there is no mechanism of doing automatic parallel. So what happens is eventually you will see that the threading has an CPU affinity. Means it sticks with one CPU and it just runs on that core or the CPU, right? Fourth, we talked about that parallel and async are two different words. Parallel and async are different. Parallel is mostly for performance, while async is mostly where you just have one thread and you want to do sometimes this, sometimes this. You just want to make the maximum usage of your resources, right? And then finally, we talked about synchronization context. Synchronization context means when the async callback comes back and your main thread is running, the synchronization context is a small thread. Synchronization context is a small thread which spawns up, right? It's a thread which connects the callback and the main thread, exchanges information so that it can merge and it can go together, right? So these are the takeovers from this class today. Let me know any questions, guys, before I end the session. And very quickly, please go ahead and share this video. At the end of the day, definitely it takes a lot of thing, to organize it. We have one of our friends out here who actually starts a Zoom call. He goes and he connects it to YouTube. I do also do some preparation 1 hour prior and I come here, right? I read something and I have to show some demos as well. So please go ahead and share this. Please visit the website here, questpond.com. We have lots of trainings, which I'm doing at this moment. Like every Tuesday, we are having the architecture training, what we are doing out there. Thursday, we are having the Angular, hands-on Angular with a project, right? Angular, EF Core, MVC Core training. Thursday and Saturday also we do it, MVC Core, right? Every Saturday, we are having the AZ204 rocking training, which is happening for Azure certification and lots of things, which we are doing out there. So guys, let me know any questions here before we close this session. I'll go back to the chat out there and let me see if any questions are there. Okay. Should I take care of synchronization context for web API? No, you don't have to, Adam. You don't have to do anything. They will take care of it. They will take care. Just watch my video of the synchronization context. It will take care of it. So Shishir, if you have bought the videos, go and watch the threading videos. Go and watch the async and await videos. Yes. Oh, from Udemy? Then buy it from my main website. Sweet marketing, right? Okay. Okay. Thank you very much, guys. And I would like to know that what can we do for the next Sunday? What is for the next session? Give me some inputs. A question here from Saikat Banerjee. I will just take this question. Async versus await, when to use? No, Saikat, you have to use both of them in one go. Async and await are like brothers. If you use async, you have to use await. If you use await, you have to use async. Your program will not compile. Async and await is one concept. They are just two keywords of C#. So they are two brothers. They cannot go apart, right? So there is no difference. You have to use both of them. Yeah. So guys, for the next session, what we should do, please put down on the chat here. And Yeah. So Varsha, Angular and MVC, we have done a lot here. Now, what is happening is we have like around like now almost 90,000 subscribers. We are going to go and cross here. Sometimes I don't get an idea what to do, right? Because there are so many subscribers. Some have come for machine learning with ML.NET. Some have come for Python. Some have come for MVC. Some have come for Angular. Some have come from SQL Server, Azure, data structures. If you see the course out there, so many codes are courses. So we sometimes don't know really what we can do best in this channel, what small thing we can do. Let us know what we can do out here. Azure Event Hub. Yep, Azure Event Hub. Okay, that's we are doing internally, Shishir. So we can do Azure Event Hub. Uh, but Azure Event Hub, the whole crowd is very big out here. The subscriber list is big. I don't know if everybody will like Azure Event Hub. Okay, Angular or MVC. So let me take that, Varsha, Angular or MVC. But you want it like, let me know if it is basic identity. I can see from Sagar. Okay, I think so. That's a good idea. Raju, can you take that? Questpond support, can you take that from Mr. Gyan here? Can we discuss the fundamental of entity framework core, like code first, do some small code out there? Why not? Like EF core is very different, right? Let us do that, I think. Okay. So I can see a lot of points out there, but that EF core has caught my eye from Gyan Prakash Singh out there. So must be I will take the EF core, and we always have the next Sunday to always take new trainings, right? Thank you very much, and please, if possible, go ahead, share this video somewhere on your uh, Twitter or on your LinkedIn. Who knows? Like next Sunday, even I will get benefited. For example, in some of the past trainings, some people gave me some awesome feedbacks, which helped me to also learn technically things, right? So thank you. Thanks a lot. Happy Sunday. Thank you.